As we look toward the 6G era, our demand for data is reaching unprecedented heights, but higher frequencies bring a new challenge: blockage. While 6G promises terabit per second speeds, these signals are easily blocked by walls, furniture, and even infrastructure. This is where optical wireless communication comes in. By using light instead of radio waves, we tap into a massive unlicensed spectrum. Whether it's focused laser beams for long distances or LED-based lighting for indoors, optical tech is a cornerstone of the 6G vision. But there's a catch. These optical links rely on a clear line of sight. One simple obstacle can bring the whole network down. Enter Reconfigurable Intelligent Surfaces, or RIS. These are the smart walls that will transform how light moves through our world. Think of an RIS as a programmable mirror. It doesn't just reflect light, it manipulates its direction, phase, and intensity. Using nano-engineered surfaces, we can now bend light without any moving parts, redirecting signals with surgical precision. By controlling the phase of the light, these surfaces can act like a lens or a prism, focusing data exactly where it's needed. In a 6G network, RIS will fill dead zones and shadowed areas, ensuring you never lose your connection even when moving. They can even compensate for atmospheric turbulence, turning a fragile, flickering link into a rock-solid 6G connection. Perhaps most importantly, these surfaces are incredibly energy efficient. They reconfigure the environment without needing massive power. They even enhance security. By steering beams away from potential eavesdroppers, they protect data at the physical layer. New star surfaces can even reflect and transmit light at the same time, providing full 360-degree coverage in smart buildings. Imagine a smart office where every wall and ceiling tile is part of the network, seamlessly handing off beams as you move. In transportation, RIS will allow vehicles to communicate around corners, avoiding collisions and optimizing traffic flow. For cellular backhaul, these smart reflectors will link base stations across cities, creating a flexible, high-capacity 6G web. The way we detect these signals is evolving too. While simple intensity detection is common, 6G will push toward coherent systems. By using both the amplitude and the phase of the light wave, we can pack more data into every second and achieve incredible sensitivity. AI will be the brain of this operation. Machine learning will dynamically configure these surfaces in real time, adapting to the environment. This combination of optical tech and smart surfaces is a major step toward a more sustainable and green 6G future. As we scale up from experimental prototypes to citywide deployments, the potential for 6G becomes truly limitless. There are still hurdles, like hardware costs and precise synchronization, but the path toward commercialization is clear. The landscape of wireless communication is shifting from active transmitters to intelligent, reconfigurable environments. We're moving toward a world where the very surfaces around us help us stay connected, seamlessly and invisibly. Ongoing research is focusing on even more advanced materials, like graphene and liquid crystals, to make these surfaces even more powerful. The goal? To make terabit per second speeds a daily reality for everyone, everywhere, using the power of light. By integrating RIS with AI and advanced optical hardware, we're building the most resilient network in history. We're redefining what coverage means. It's no longer about where the tower is, but how the environment helps the signal. Every window, every wall, and every billboard becomes an active participant in the 6G ecosystem. The result is a network that adapts to our needs in real time, rather than making us adapt to the signal. In industrial settings, RIS will enable ultra-reliable communication for robotics, even in the most obstructed environments. By leveraging passive technology to do the heavy lifting, 6G will be more efficient than any network before it. We're seeing gains of up to 10 decibels in shadowed environments, a massive leap for wireless reliability. The synergy between radio frequencies and optical waves will be the hallmark of the 6G era. Advanced materials are at the heart of this revolution. Metasurfaces allow us to do things with light that were once impossible. From bending light around obstacles to perfectly focusing it on a moving target, the physics of our world are being rewritten. Privacy is also improved. RIS can create safe zones where data stays confined, preventing interference and snooping. Global standards are now being developed to ensure these smart surfaces can work together across the entire 6G network. This isn't just a small step, it's a leap in how we connect. From deep space to deep underwater, the network is everywhere. Even underwater, smart surfaces can overcome the challenges of light scattering, opening up a new frontier for data. High-altitude platforms and drones will use RIS to maintain stable links even while moving through turbulent air. The 6G ecosystem is complex, but smart surfaces are the glue that holds it all together, ensuring reliability and speed. To summarize, We're building a network that is faster, more reliable, and more efficient than ever before. Reconfigurable surfaces are the key to this transformation, giving us control over the very environment where data travels. They are the bridge to the 6G future, turning our cities into intelligent, connected landscapes. We are just at the beginning of this journey. The potential of smart optical surfaces is just starting to be unlocked. As we continue to innovate, the lines between our physical world and the digital network will continue to blur. The future of connectivity is bright, intelligent, and optical. Welcome to the 6G revolution. Subscribe for the latest updates on the 6G revolution, lighting the way to a connected world.